right. Hi, everybody. We're actually going to start with video number 4 because I had planned the class out and then made some changes. So this is going to be, even though it's really your first note video you're doing for me for this class, this is going to be video number 4. We're always going to start them like this. I want you to label your notes with the video number at the top. And then over on the right-hand side, the chapter and section. So this is chapter 2, section 5. And then I'll put what we're doing underneath of it. And what this video is about is it is all about rational exponents. And just a reminder that the word rational also means fractional. So we're looking at fractional exponents. And there's a bunch of rules of exponents I just want to remind you of, not necessarily fractional exponents, but just rules of exponents. So that's where we're going to start. Rules of exponents and how they behave. And there's a bunch of them that we're going to list. So the first one is going to be rule A. I'll refer to these later on. This is the product property. For exponents, and it looks like a to the m times a to the n equals a to the m plus n. So if you have the same base with different exponents, you add your exponents. A numeric example of that, here I'll give you one even with coefficients on it. So if we have 2x to the third times 4x to the fourth, we would multiply the coefficients. That would give us an 8. And then these guys adhere to the rules up above. So x to the third, x to the fourth, they have the same base. You'd add the exponents. So we would get x to the 7th. And that would be how that guy would look. Okay. The next one is B. And it's called the power property. And that property looks like a to the m to the n is a to the m times n. So in this case, one base, two exponents, you're going to multiply those exponents together. Let me show you an example and then a numeric example. So if you had, let's say just x to the third raised to the fourth, then you're going to multiply those together. So you would have 3 times 4, and you would get x to the 12th. Now, be careful if you have a number in here, because if you have something like 2x to the third, and it's raised to the fourth, well, there's also this other little rule. This is kind of like rule C. It's another power property. If you have a and b to the m, that is a to the m times b to the m. So that means this 2 gets raised to the 4th power. And then your x to the third, these would get multiplied. So you'd end up with x to the 12th. And then I would expect that you would actually simplify that. 2 to the 4th means 2 times 2 times 2 times 2, right? And that is 16 x to the 12th. So that's what that would look like. So be careful if you have an exponent. Just don't forget to do that. All right. D is the quotient property. You may or may not remember that a quotient is the answer to a division problem. So the quotient property looks like a to the m over b. Oh, I'm sorry. That's an a. Over a to the m over a to the n is a to the m minus n. So you would subtract those guys. A numeric example, if you had, I'll just put that one over here. If you have x to the 7th over x to the 4th, you would have x to the 7 minus 4, which is x to the 3rd. Okay? So that's D, the quotient property. All right, next we have to deal with negative exponents. So E is the negative exponent property. And this looks like a to the negative m, so some base to a negative power, ends up, you put a 1 over the base and you make the power positive. All right, so numeric example of that, if I had something like, for example, x to the negative 7th, that would become 1 over x to the 7th. So you just put 1 over, it automatically becomes a fraction. You should actually think about that. Okay. There's kind of an offshoot of this guy, though. It's also a negative exponent, but if you end up with two bases, a over b, and they're raised to a negative power, then what happens is the a and the b flip. So it becomes b over a, you get the reciprocal, and the power becomes positive. Okay? Example of that guy, if I had, let's say, I'll go back to the yellow pen. Nope, something different. If I had 2/3 to the fourth power, negative fourth power, sorry, I would rewrite that as the reciprocal of the parentheses, so 3 over 2. The power becomes positive, and then I would raise 3 to the fourth, so this would be 3 to the fourth over 2 to the fourth, which is 81 over 16. You just separate these and do the top and then do the bottom. All right, and then G, and this one is kind of what this whole section is about. Like I said, those ones you need to remember. But G is called the rational exponent property. And it allows you to take something written as a rational exponent, a to the m over n, and it allows you to use this rule to turn it into a square root. So you take the root, the base is the a, that goes underneath the root. The n is actually the index. Remember this little guy, you should know this from your last class. This is the index. And that's the n is the index. And then the m becomes a power on the entire thing. So it can either be written like this, or it can be written like this, the nth root of a to the m. So whichever way works out better for you to do that, either one of those is valid. So this is kind of, this one right here is the nuts and bolts of this section. We want you to be able to take something with a rational exponent, fractional exponent, and turn it into a radical expression and then simplify it. Okay? So I'm going to go to the next screen and we'll give you a couple of examples of what those are going to look like when you're going to get those. Okay? I'm going to write the rule at the top of the page as well. So here's the rule. Remember, this is G, the rational exponent rule. Says a to the m over n equals the nth root of a to the m, or the nth root of a to the m. So we'll have to see which one is easier for you to manipulate. Here's what this problem is going to look like. Convert the fifth root of x to the third to a rational exponent. Okay? The more you're familiar with your vocabulary in this class, the better. And in your head, if you read these directions, highlight the word read the directions. When you see that word rational, you should think fractional, and then you should be thinking that you're going to be using that rule at the top. So we're actually given this, and we need to write it like that. Okay, so can you do that? Why don't you pause this, write out what you think it would be, and then come back and see if you're correct. And if you're not, see why. All right, so if you paused, hopefully you wrote these down. So you're given what's in this green circle up here, and we're going to rewrite it like that. So what's the base of this thing? That's where you should start. The base is the a, and that's, in this case, the x. And then you want m over n for your fraction. Well, 3 is the m. This is your m. and 5 is your n. So this is going to be x to the 3/5 power. And that is all you need to do. Now, if you're not terribly not terribly familiar with varsity, remember that in varsity, when you're just going to type in the x, and then a caret stands for your exponent. And then because this is a fractional exponent, you're going to want to enclose it in a set of parentheses. So you would actually type that. And then there's a preview button. And if it doesn't already show you, hit the preview, and it should write out what it would look like in mathematical terms. So it should look like what you have on your paper. Okay. You can also remember in the bar, the preview would be here. This is your answer bar. And there's a little yellow section over here in the yellow answer bar. When you click in it, you have to click in it to make that active. And inside of it, there's a little up arrow. And if you click on this, you get yourself an equation editor. And inside that equation editor, you've got fractions, you've got radicals, you've got all sorts of things. So you could just type the x in, hit the equation editor, go get yourself a exponent. You'd hit the exponent button, and then it would put it up here, and then you can make that exponent a fraction and just type in the 3/5. So it depends on the way you like to make that work for you. Okay, let's look at another example. Convert 16 3/2 to a radical and simplify. Okay, so now we're using, if we have a to the m over n, that is the root of a, n is your index, and then raise it all to the m power. So you're given this side. Now we're going to turn it into that and then do what it says. Okay? So if I turn it into that, underneath the radical goes a. Well, a in this case is the 16. This is your m, and n. So your n becomes your index. So that's a 2. And then this is cubed. So what's the square root of 16? Well, this whole thing inside the parentheses would, square root of 16 is 4. And now you're going to cube the 4, which means 4 times 4 times 4, which is 64. And that would be the answer to that problem. Okay? All right. This one's just kind of a reminder in case your math skills got a little wonky over the summertime. What if you have a negative 216 to the 2/3? Okay, well, the power is not negative. We're not looking at the negative exponent power. The thing that's negative is underneath of here. So this problem is just like the one up above. We're going to use that same rule. So inside the radical goes negative 216. This is your m and this is your n. So the n is your index. And then this whole thing is going to be squared. Now, remember, if your index is even, 2, 4, 6, 8, whatever, you cannot take the root of a negative without having an I in your answer. Okay, however, if the root is, or if the index is odd, and it's negative under the root, then you will get a negative answer. Here's what I mean, right? If I take negative 6 times negative 6 times negative 6, negative times a negative is a positive. So this is positive 36 times negative 6, which is actually negative 216. So if I'm taking the cube root of that number, I'm multiplying -6 by itself exactly 3 times. So it's a perfect cube as a negative. And so this equals -6. Okay. So you can have a negative under the radical as long as your index is odd. All right. So if that didn't come up in your Algebra 2 class, we want to make sure that you're aware of that. So the cube root of -216 is -6. And then you're squaring that. -6 times -6 is +36. Okay. So that would be the answer to that problem. All right. How about the negative? So this goes back to the negative exponent property, which are E and F. We want to look at those. So property E and F from the earlier pages in your notes. All right, so here is how this works. Remember that the first rule is a to the -m means 1 over a to the m. So this is as straightforward as something like 2 to the -3rd power. Anytime you see this negative in the exponent, you should be thinking fraction. And so you're going to take the whole 2 as the base. Your -m is your -3. You're going to stick a 1 over it and make the power positive. And you're never going to leave that like that. You would actually do that math. So 2 to the 3rd is 8. So this is 1/8. And that's how you would utilize that version of that property. And then you have, let's do another example. If you have 16 to the -3/4, well, now we're going to have 1 over 16 to the +3/4. And utilizing what we just learned with the rational exponent rule, we can take that guy and write it like this: 1 over the root of 16. Your index is 4. And then your power is 3. Well, the 4th root of 16 is 2. So this is 1 over 2 cubed, which is also 1 over 8. So these two things are actually equivalent statements. Isn't that bizarre? They don't even look anything like each other. All right. And then property F, the one that I mentioned over there, if you have a fraction. Hi, hello, this is Heather. Hey, what's up? Yeah. What time can you? Yeah, I can do that. I sent you a text. I said I just need about 2-hour leeway to get to the barn and all that stuff. All right, that sounds fabulous. Thanks. All righty. Bye-bye. Sorry about that phone call. That was my vet calling about my horse. And I can't hit pause on these videos, and I don't want to redo it. So you had to listen to that whole thing. All right, so continuing on here, the 25/64 is raised to the -1/2 power. All right, so in F, here's what this rule said. If you had some fraction, let's see, this looked like a over b to the -m, then you could write that as the reciprocal to the positive power. So if we take the reciprocal of what's in the parentheses, we end up with 64 over 25. And then we make this power over here positive. Okay, and then that means we have 64 to the 1/2. You just apply that exponent to the top and the bottom. And then I can take, now 1/2 would be the square root, right? The 64, the 2 would be the index, the 1 would be the power. 25, 2, and 1. So the square root of 64 is 8, and the square root of 25 is 5, and that would be the answer to that problem. Now that's my home phone going off. Just ignore that. All right, so the next couple examples we have, just to make sure you can do these problems and you don't wig out, these go back to the earlier properties that you have. So here's some generic, and I know that they're going to ask you for these in varsity, which is why I want to make sure I go over them. Exponent examples. All right, so the first one is x to the 1/5 times x to the 2/5. Well, this is going back and utilizing that product property. So this is property A, and that says that if you have the same base with two exponents and the bases are multiplied, you add your powers. So this is x to the 1/5 plus 2/5, which is x to the 3/5. And you would leave that like that if that's all you're asked to do, okay? The next one utilizes the quotient property. So this was property D. And this example looks like, actually, it uses D and E, but we'll get to that. X to the 2/5 over x to the 3/5. And the quotient property said if you have the same base and two exponents, you subtract your exponents. So we have, it's always top minus the bottom, 2/5 minus 3/5. And if that's the case, then I get x to the negative 1/5, and you can never leave a negative exponent. In your answer. And so now we have to use property E, which is the negative exponents, which would make this 1 over x to the 1/5. And you would leave that like that. Okay? And then the last one utilizes the power property, which was property B. And that one has something like x to the 1/2 times x to the 2/3. And I just want to comment about you guys and how you write your fractions. I would much prefer you write your fractions one over the other like this instead of next to each other with a slanted line. These get very difficult to read. The only reason I sometimes revert to that on here is the amount of space it takes to make them look good if I write them the way you should, which is A over B, not A/B. Okay, so down here in the green, we have x to the 1/2 times x to the 2/3, and that's all raised to the 3/4. So the power property said if you have a to the m to the n, that's a to the mn, and you're multiplying those powers. So this is x to the 1/2 times 3/4, and then you have, oh, I'm sorry, this should have been a y. Will you make this change here, please? That's a y. And then we have y to the 2/3 times the 3/4. And then you just have to do that multiplication. Or remember, when you multiply fractions, you're multiplying straight across and then simplifying if possible. So here I get x to the 3/8. When I multiply 1 times 3, I get the 3, 2 times 4. And then the y, I get 6/8. But you need to make sure that you're reducing that. Oh, I'm sorry. That's 6/12. Good Lord. 6/12, which is 1/2. And so that is y to the 1/2. And that's the answer to that problem. Even with my little boo-boos in there, I think you'll get the gist. So, all right, that is, I think, all we have on your rational exponents. There's a whole bunch of different problems in varsity that kind of range all over the place. So if you need any help, just come and let me know. All right, and this is our first real video that we've done together, and I like to end these with a toodaloo, so toodaloo.